Welcome to the video where we're going to walk you through PL SQL. PL SQL is a procedural language that is an extension of Oracle databases. And if you're familiar with some procedural languages, this will be somewhat familiar to you. If you've never used a procedural language before, you've never coded before, well, we're going to walk you through some basic concepts of coding, such as if statements, loops, and some other complex things that exist as part of this PL SQL language. Now, PL SQL is kind of a limited language compared to other languages because it is designed specifically to work with Oracle databases rather than general purpose programming. So the goal of this exercise of learning a little bit about PL SQL is really not to focus on learning a valuable language that you're going to use all the time, because it is designed for Oracle applications. If you're going to go out there and build applications on Oracle, it's going to be something you might use. But for the purposes of this class, we're just trying to show you how you can actually write procedural language that has logic in it and still combine that with SQL. Now, before we jump into it, I'm going to actually walk up here a second and spend a second just talking through a few different things. When we create this procedural code, it will have kind of four major clauses that you can use. That is the connect, the declare, the begin, and the exception. Now, the only one that's actually required is the begin. And the begin is where all of the code is truly going to begin. All of the meat of the code is going to run. But to take a step back, the connect clause is where we'll actually connect to the database and run it if we're not already connected. Now, as you already know, when you use SQL Developer, you actually go and connect to the database. So there's going to be some code down here that I'll show you later on where you'll see this connect, and it's using this user called AP, and then the password of the user is AP. Not very secure password, but it's actually just a fake user that the book creates as part of practice problems, and we actually create your own user for you, and and so you don't need to use this. So I'm gonna just actually remove this from the code, and you won't see it in there. You'll see it in the book somewhere, but we're not going to need to use that code anywhere here. Now, back up here, I am going to use it one time just to show you what it does. So let's talk about connect, declare, begin, and exception. So what's happening here is that when we are building an application, the application itself is going to have some code in it that's going to look potentially something kind of like this. If you put your code on in the application side of things, it's going to, let's say we want to check a vendor's balance due, and in this case we're actually going to check a specific vendor 95, and it's going to basically respond to, if the balance is above 0, it's going to actually respond with the balance. But if the balance is not above 0, it's going to say the balance is paid in full. So we're going to walk through what this is actually going to do. I'm actually going to use my username, and I'm going to use a password that I've just created called Hook'emOracle12. Now, just in case you're wondering, if you go out and try to log in with this username and password, by the time you watch this video, I will have already changed the password. Because this is not a very secure password. But if I run this little piece of code right here, and let's just zero this out for a second. What it's going to do, I'm going to run it, and you're going to see that it connected. And as soon as it connected, it actually disconnected. Now, the reason why it disconnected is that it connects and it expects that it's supposed to run some procedural code. Well, it didn't. So therefore it disconnected. So if your application was, let's say, you're using your application on your computer and then you're about to hit save, the first thing your application should do is go and connect to the database before it can go and do all of its, whether it's saving, updating, inserting, or just pulling data from the database. So that's something to get your head around, is that applications, when they need to connect the database, they will connect. And they connect just like you and I do. They connect with a username and a password. They will probably connect with a system user, not just a personal user like this. The next thing, this line here that the book talks about, is that when we run this, what this does is it actually allows us to output text. If you don't run this set server output on, you will not get responses back from the server. So this is basically telling the server, hey, turn your output on so that we can see the responses we're getting from you. As we get further along here, the declare area is where we will actually declare variables, and variables are basically just ways of storing data. So if you've ever used a procedural language, you'll know that you can actually create variables just like you can do in algebra, right? You can create a variable of x and store a value in it. And in code, we can create a variable called sum balance due variable. It's a number with a length of 10, precision 12, and it is something that we can store values in. So if you're ever going to use variables in your code to store values and reference in your code, you'll need to do that here. As we jump into the big part of this code, it's the begin statement, and what you'll see here is SQL. The only difference is that you're going to notice there's this into, and if we take this out for a second and just run this statement, let's look what this does right by itself. I mean, you should know what this is doing because it's just selecting the sum of the invoice minus payment minus credit total from invoices where the vendor is 95, and you'll see here that the balance due for the vendor 95 is 171. Now, let's jump back here and look at what this is doing. If you look at this, you might be able to think about what it's doing. It's actually taking the value that we selected from this table for vendor 95, but it's selecting it into this variable. So what we're going to do here is in PL SQL, we actually can use a little bit of a modified version of SQL to select values from our tables into a variable. So when we run this, the first thing it's going to do is run this select statement, and it's going to save that value here in this variable. Now, as we get further along, we're going to do an if statement, and we'll talk about what if statements are if you've never seen one, but it's doing an if statement, if you've used Excel, you probably use an if statement, but an if statement is going to check something. It's going to run a test. And if that test is true, it's going to do one specific thing. Otherwise, it's going to do another thing. And we could do multiple checks, but this is going to be a simple. If this is true, if this is greater than 0, which this value, we've selected 171 and stored it in this value. If this is greater than 0, it is going to output this string of code. And the DBMS output.put line, basically this is a function, and when we feed in some information to it, it will return a nice text response to us in our script output. Just like a function that you've used before, like sum, you can say, hey, give me the sum of something, so you'll feed it some data and it will spit back a number. The put line is a function that says, go feed me some text and some values, and I will spit it back to you in a nice formatted text. So that's an actual function. So basically it's saying, hey, if this value that we've stored here is greater than 0, I want you to spit out some text that says the following: balance due, and then this rounded sum balance variable. And if it's not greater than 0, it's going to just say balance paid in full. And then that's the end of that whole logical statement. And then down here, if this last piece, if there's an error in this code somewhere, it's basically going to spit out an error has occurred in this script. And then the code will end. And note here, when you do end your code, you do need to have semicolons and a dash here at the end, a slash here at the end. This slash actually is important. So I'm just walking you through the format of the code itself, but let's actually go through and run this itself. So I want to go through and I'm going to hit play. And as I do it, you'll notice a few things happened. The first thing that happened is that this code connected to the database, which is what this line is doing here. The next thing it did is that it turned on server output, which will basically allow the server to respond. If we didn't do that, you would not see this response here. So it turns on server output, and then it goes and creates this variable that's a number. It selects this payment balance or this balance due into that variable for vendor 95, and then it makes a decision. If this is greater than 0, then it's going to output this, and because it is greater than 0, it outputs balance due $, and the balance rounded to the nearest decimal, second decimal, which is exactly what you see it just did. And then if there was an error, which there wasn't, it will skip this part of the code and it ends. And then it basically lets us know that the procedure has run completely, and then the statement disconnected from the database. So we're going to walk you through a little bit more of that, but going forward, what we're going to do is we are just going to not need to connect to the database, because again, I'm running this from within SQL Developer and I'm already connected to the database. So this is the exact same piece of code, and I'm just going to hit Control Enter and run the code. And if I erase this for a second and run that again, you'll see it runs fine. Now, just to be clear, if you don't run this, you'll probably get something that just says PL SQL procedure completed. If you don't run this statement here, you won't get this balance due piece back. Now, once you've run this once and you've made that happen, then you can go and run these without having to run this. So you only need to run this one time once you're connected. Once you're connected, you don't need to run it again. Okay, so let's move along and let's talk about. We've already kind of talked you through this example of running an anonymous SQL block. And to be clear, what anonymous means is that we don't actually name this block of code. It's just a piece of code that we are running. Later on, when we talk about functions and procedures, we'll actually be able to create our own functions, like you create, just like the sum function or this put line function. We'll actually be able to create a function and use it in our applications or anything we want. And these procedures will actually be stored in the database. So what we'll do is we can have an application that says, calculate tax, and we can call from our application and send a message to the server and say, hey, here's a total amount. Will you calculate the tax for me? And we can have a function that goes and calculates the tax and returns a value and spits that value out. And that's kind of what a function does. So an anonymous function or anonymous code here, you just run it within your SQL Developer. When you have the non-anonymous code, which actually is we're going to give it a name, you actually, when you run it, you compile it out here and you store it on the server. So you're not going to be running it from here. And that allows applications, again, to be able to call this database and have some of this logic stored on the database. All right, so let's jump into our next statement here. So we've already kind of walked you through this. If you were to go and run this statement here by itself, you're gonna get nothing back if you haven't run this. So this is just reminding you to make sure that you turn on your server output. So again, if you get something that looks mainly just like this, that's your problem. So in this example, this is just showing you how procedural code uses or PL SQL uses variables. Now, I want to make one clarification. As you run this code, you do not want to run it as a script. If you do want to run it as a script, you need to make sure you've selected everything and run just the selected portion. You can also just run it as a statement, and it will run everything from the declare or the begin to that slash. So let's look at what this code is doing. So what I recommend is, as I'm learning this, I typically will run the code, and I'm just looking at what it's doing. So it spits out these 4 things. Now, I'll explain what this commented version looks like here. But what this is doing is we've created a couple of different variables here. One called max invoice total, a min invoice, percentage difference, the count invoice ID, and the vendor ID variable. Now you'll see here that these have been declared with a data type. This is going to store a number. Now, oddly enough, you don't actually have to specify a data type if you don't know it. What you could do is you could say, I'm going to have this variable called max invoice total, and I don't know what the invoice total is, but I want to basically copy whatever data type the invoice total on the invoice table is. That's what it's doing here. So it's effectively, if we know that the invoice total, in this example, let's say invoice total here is a number, then that would be the same. If we knew that, we could just go in here and say, all right, create a variable called max invoice total and declare it as a number. But in this case, they're just showing you that you can also just kind of emulate the data type of a column in your database. So for me, I like to be more explicit and definitely call it out. And I would definitely go check, hey, before I go and start storing a variable that's going to, creating a variable that's going to store invoice total, I would have gone and looked up what the invoice total data type was. So I'm going to, store it like this. And again, so now we have these variables. So let's go and look how they're being used. And if you need to ever know how they're being used, you can click on one and it'll show you where that variable is being used. So here we're selecting the max invoice total, the min invoice total, and the count. And we are selecting that into these three variables that we have created. Now, we're pulling that from invoices where the vendor ID equals the vendor ID variable. Now, the vendor ID variable, actually, you'll see it doesn't get a value down here, but it is being defaulted to the value 95. And so what that's doing for us here is that we've declared these variables. This is actually getting a default value of 95, and it's going to go and select the values for our vendor 95 into these variables. Once it has that, this percentage difference is actually going to go here, and it's going to take the max invoice total, which we've already selected. And if you want, we can just go see here what the max, let's go look at what it does. Oh, sorry, let's do this real quick. Let's run just this piece here. So you'll see here it's 46, 16, 33, and 6. And so what it's going to do is it's going to subtract 16, 33 from 46, 21, and it's going to divide that by the min times 100. Now, I'm not going to do that math in front of you because I know it's going to be right. But basically, it's going to select those values in here. And now that they're stored as variables, and some of y'all have talked about this in class, like, why can't I use an alias in the where clause, or why can't I use an alias once I've defined it in my select statement? Why can't I do calculations with the alias? Well, you can't. But in this scenario, if you want to create a variable, now that we've created it and given it a value, we can refer to it down here. So the percentage difference is going to end up being this math here. And then what this will end up doing is outputting the max invoice, and then we're actually going to grab the amount that we selected. It's going to output the min invoice with this little, literal string here. It's going to output the percentage difference, which is just calculated and stored in this variable here. And then it's also going to output the count invoice ID variable with this string. So kind of look at this string here, take a good look at this, and then let's run this one more time and see what we get. So you see here exactly, we're getting the max invoice total, we're getting the min invoice with the invoice total, we're getting the percentage difference, which is what the math here gets calculated, and we are getting the number of invoices, which we saw it earlier grab. So this is just showing you how you can utilize variables and how they go about being fed into the code and being used, to do arithmetic or to, be part of the output. So how do we code an if statement? So an if statement follows a pretty standard set of syntax, and it's not going to be that unfamiliar if you've ever played with an if statement before. So we're going to grab a variable called the first invoice due date, and what we're going to do is we're going to select the min invoice due date from invoices where there is a balance due. So let's, just for the sake of this, run just this code by itself so we know what that date is. It's June 9th, 2014. And so what it's going to do is it's going to select that date into this variable. And then it's going to look at this. And it's going to say if, so an if statement is basically going to have this syntax. If whatever your test is, then, and if whatever that is true, it's going to, ask for you to provide a piece of output or whatever you want to do. You can do another if statement. You can do whatever you want. Either way, you need to end this statement here with a semicolon. Same thing here. Same thing here. You will end your if statement itself with an actual semicolon. Keep in mind, as you'll start to notice this. Each part of the code, like when you're declaring a variable, ends with a semicolon. Your SQL statement at the very top will end with a semicolon. But you want to be careful not to be putting semicolons everywhere. And it will tell you if that's an error. But basically, it's going to go through here and check if this is true. And if it is, it's going to output outstanding invoices due. In this example, we actually throw in an additional check, which is if, and to do that, we else if. If you type else if all in one letter word, it's not going to work. It actually is ELSIF, but means, so it's saying if this isn't true, else do this if statement. If this equals the sys state, then output this. Else output this. And then again, it ends the if with a semicolon. And don't forget, we do the end at the end of every PL SQL, anonymous SQL, PL SQL, and we always need to have that slash. If you don't put that slash there, it actually does not terminate the code correctly. So if I went through here and ran this, it would not. It would run if I actually select the whole thing, but this kind of acts like a semicolon, and it lets us know where to stop when we're running the code. Now, you'll notice here we got some other stuff here happening, a case statement. I'm going to skip that for a second, and I'm just going to hit Control-Enter and run this. Now, you'll notice when we run this that it says outstanding invoices due. And that should not be a surprise because the June 2014 date is definitely before the sys date. Now, if you want to just see, is this actually going to work? How could we test it? Well, we could actually go in and do something like this. We could go in and update the invoices table, and I could set the invoice due date. And what I'll do is I'll set it equal to add months. And what I'll do is this. If I think about this for a second, it's June, so I'd have July, August, September, November. So it's like, and that's 5 years behind me. So 12 times 5, give me 60 plus another 4. Let's just be safe and let's just say, 5. You can actually feed in arithmetic like this. You can also just say, go add 65 months. So to make it less confusing, I'll just do that. And watch this. I'll quickly go and run this. Okay, it's updated all the rows. Let's do a quick select star from invoices. What we'll do is let's just grab the let's go grab the min invoice due date. Let's see where we're at. Oh, I didn't add enough. Interesting. It's September 2019. Let's do this. Let's just add one more month. We'll add one more month. Actually, let's add 2 more months because that will put us in November. and that'll work for sure. All right, here we go. So let's select, in fact, let's just do this. Let's grab this whole thing. All right, we're gonna run this. All right, January 20. Either way, well, I added a lot more months than we needed. So now I'll simply just go back here and I'm just gonna run this code again. And now it says no invoices are overdue. And that's because invoice date is not before the sys date, it's not equal to sys date, it's actually after. So that just kind of shows you how to test your code. All this is showing you here is that you can also run this entire piece of code as a case statement. So this case statement is saying, hey, when this is less than sysdate, then do this. Again, ending with a semicolon. When it is equal to this, do this. When else, do this. So it's no different than an if statement. And some people like to write their logic in case statements. Some people like to do if statements. If I run this whole code again, it gives me the same output. So pretty cool. You can kind of play around with that. And as we progress on, let's talk about case statements a little bit more and just show you an example of how you can use them. So case statements here in this example, we are grabbing a variable called terms ID, and we're going to select the term for invoice 4 into this variable. And now it's going to look at this term and it's going to say, hey, when this term, when 1, output this, when 2, output this, when 3, output this. So let's just run the code. And if it helps, I'll erase it and so you can see it. So it says that net due in 30 days, which means that it should be 3. So let's just actually go run this and see what it turns back. Sure enough, it's 3. So again, what it's doing is we've declared a variable, we've selected the term ID 3 for this vendor into this variable, and then we've gone and checked, and basically here's where it said, oh, when it's 3, it's going to output net 30 days, which is why it ran this. Now, there is another way that you can look at this case statement, and you can use a search case statement, which we've kind of already talked about. It's instead of actually calling out the specific column and you saying where 1, it actually, you can use an operator and you can say case and you can say where terms ID variable equals 1, do this. This is redundant, it's the same thing, but it's something that, if you wanted to do a range of data, like saying if, let's say for some reason, if terms are greater than 1 or, less than 0 or something like that, you could use a search case. I'm not going to run this one for you. If you want to uncomment it, just make sure that you're uncommenting both the start and end part of that comment, because this is a spanned comment. But check it out if you're interested. So how do we code loops? So sometimes you want to do something in code and you want it to repeat a certain number of times. You can think about, like, let's say we want to upload someone's grade into Canvas and we want to grab a spreadsheet and upload it. Well, what will happen is as you load that spreadsheet in, it's going to create kind of a long list of UTIDs and grades, and it's going to process them one at a time. It's not going to just do this mass save. So it's going to loop through and check it and make sure it's valid, and then it's going to save it and it's going to go through to the next one. And you can set loops to loop a specific amount of time. You can hard code it to say run 3 times through. You could also say, hey, if this list is 20 rows long, run this loop 20 the count of rows we have in this loop, in this list. Now I did mention that we are going to skip while loops and simple loops. They're no different in terms of what they logically output. The simple loop, ironically, is a longer way of writing the loop. The while loop, if you want to check it out, you can see how that works. What the while loop is basically saying is, while this value I is less than 4, we want to output it, and then you can go and basically add 1 to I, and so it'll keep looping through it, and so it's like it'll say, all right, the value is 1, it's not less than 4, go do this thing, and then it adds 1, and now it says, okay, the value is 2, it's still less than 4, go loop through. So while loops are another way you can do it. We're going to use the for loop, which is basically a simple way to do it, and you can use it later on in some other PL SQL. So what we're going to do is we're going to just use the begin. We're not using a variable. We're not doing any exceptions. And all this code is going to do is it's going to output this first line right off the beginning. If I took this out for the example, and I just did this, erase this, watch what happens. If I just run this, it's going to say beginning the for loop. And then it says the procedure ran correctly. So now we're adding in the for loop. The for loop has a specific syntax where we're going to say for I. So I is going to be our variable, and it's very common in for loops or looping that you just use a variable, a single variable. I is very common, and so we'll just say where the I, and I, you can kind of think of it, this is like the incrementer, because we're going to start with a value of 1. That's what this is saying here. So we're going to say for I, in this loop, we're going to start at 1, period, and this is going to say 3 is where we want it to stop. So what this is effectively saying is we want this loop, it's going to start a little counter or an incrementer at 1, and it's going to loop through this process. And when the loop is, when it's gone through its loop and it's gotten here, it's going to go back up to the top, and it's going to automatically add 1 to that. And here, so it would add 2, and it would say, okay, it's not 3 yet, so it's going to run through this code again. Then it's going to add 1 to that incrementer, and it's going to say, okay, it's not over yet because 3 is the last number in the loop, and it's going to run through this again. But as it goes through here and it loops through 3 times, you'll notice here it's going to do it in a literal string of I colon concatenated with I itself. So if you think about it, it's going to end up printing I equals 1, and it's going to loop back up, and it's going to say I equals 2, loops back up, I equals 3, and by the time it loops back up, it's going to go, oh, I is 4, this loop is done, and it's not going to run it anymore. So let's run it. And there you have it. Whoop. Be very careful, I guess, when you're running this code. All right, so let's erase it. Let's run it one more time. Don't run it as a script. Run it just as a statement. And so sure enough, it ran the begin for loop. It actually then starts this looping process, and it outputs I equals 1. It loops back up, and it says I equals 2. It loops back up. It says I equals 3. It loops back up, and it says up 3. It's 4 now, and this procedure is going to stop. And so then it jumps back down to the end of the loop, and if there was anything else here, we could get it, we could get it to do something else. Like, for example, we could add this in, and I could run this statement, and sure enough, it runs the loop. So you'll see here it's actually kicking off the beginning. It loops through this 3 times, and then it runs this. So it doesn't run this until the loop has ended. There you go. Pretty cool. So if you want to play with a while loop and the simple loop, feel free. They're just more syntax to learn. But if you can do it one way, I'm not going to teach you the other 2 ways to do it because it's not necessary for the purpose of this. We're not getting into procedural language that deeply in this class. I just want to get you kind of introduced to it. So this next one is called a cursor. Now a cursor is it's a little complex because what we're talking about here is how do we go and collect groups of data or a mass of data, and then how do we kind of incrementally walk through that list or list of data and then grab things from it as we need it. So in this, we're actually going to declare a very special set of variables. The first one is, it's not like any other variable that you've ever created where you take a variable and you call it a number or it's a date. We're actually going to create a cursor, and the name of that cursor is called invoice cursor. And let me explain kind of what a cursor is it's a special variable that simply can store more than one single value. If I had to relate it in some way, I would do it like this. I would say, let's actually run this statement here without everything, and let's just get the output of it. All right, so here's the output. It's giving us the invoice ID, the invoice total from invoices where there's a balance greater than 0. Now I'm going to spit this out into Excel for a second, and then I'm going to emulate this here. So it's called the invoice ID and the invoice total. All right. So the first thing that happens is that the cursor that we've defined, it's defined as, so it's a cursor called invoice cursor, and it defines its value by using this is keyword. And I wouldn't expect you to have to memorize all this syntax and regurgitate it on tests, so don't worry about that. This is all, you'll need to reference these kind of things if you're going to write it later on. But it's going to grab all of this and it's going to store it in this cursor. So when we say that, we're meaning it's storing all of this information in the cursor. And for simplicity, I'm just going to take this out. So all of this here is stored in the cursor. So let's just make that clear. All right. Now, or actually, it's really just storing the values. Now, this next variable here is called the invoice row. Now, again, it's getting a data type that you've never heard of, and that data type is called row type. And what that means is that it's going to store the invoice information that is in a row. And if you remember earlier on, we actually showed you how when you declare variables that you can model or emulate the type of a specific variable, and emulate the specific type of a certain column. So I could say, I'm declaring this variable and I want it to have whatever data type is in this column, which was a number. But down here, what we're doing now is we're saying, hey, I'm going to create this variable called invoice row, and I want you to go to the invoices table, and I want it to basically copy the data type of all of every column in that row. And so I want you to think about it like this. If this is the cursor, and that's what the cursor stores, this invoice row variable is going to store something that will end up being a number and another number. Or an example that would be, it's going to store, this and this. Now, it's not going to store just that, because what we're going to do is, as you go through this, you'll see that we have a for loop. And what we're doing, instead of saying I is going to be the incrementer, we're actually going to start at the first row in the cursor, which is essentially saying we're going to start here on this row, and we are going to just make sure we're capturing all this. So it's going to start here at this row in the cursor, and it's going to start the looping process. And you'll notice this kind of follows the same structure of the for loop up here, except instead of the I and where does it start and end, a cursor, it's already implied when you're saying I'm using this cursor, it knows where it's going to end. So it actually knows the number of rows in that actual cursor, and so it's going to basically start at that first row and it's going to go to the last row. So what we'll do here is we'll say, okay, now that I've actually got this row, I can actually refer to anything in that row, the invoice total or the invoice ID, as I like. And I can do that by just simply saying the invoice row dot invoice ID, invoice total. And So what that's going to do, it's going to look at the invoice total in this row, which is 2,558 or 551, sorry. And if it's greater than, so if this number here is greater than 1,000, then what it's going to do is it's going to update the invoice table, and it's going to set the credit total equal to credit total plus invoice total times 0.1. And then it's going to do that where the invoice ID equals whatever the invoice ID is in this row total, meaning this guy right here. So after it's done, it's going to say one row was updated for this ID, and then it's going to end the if statement, and then it's going to wrap the loop up, and it's going to say, okay, it's going to go back up. And then it's going to continue this process here until it goes through, and it's going to continue to evaluate. It'll evaluate this one, it'll evaluate this one, it'll get to this one though, and look at this, this is below 1,000. And it's going to get here, and it's going to go, that's not below 1,000. So it's going to skip all the updating. It's not going to output anything, and it's going to loop back up. And it's going to continue to loop through each row. And the cursor allows us, again, to just go and grab, once we've defined this row as a variable, we can refer to parts of it. So I like to think of it like this, like a variable is usually a single value. Now we're actually storing a variable like a list. And you can make a cursor as big as you want, and you can define its row as a row type, and then you can refer to anything in that row as you're looping through it. It's pretty powerful. And this last piece of code here is actually rolling back the update. So if I run this whole statement, you'll see here that it's gonna do this. It's gonna go through this if statement, and it's gonna say, all right, you know, one row was updated for invoice 3, one row was updated for invoice 6. You know, if you'll notice here, like here's invoice 3, invoice 6, they were updated. Invoice 15 was not updated because it's not above 1,000. But then as it ran through all this code, it actually rolled it back, meaning that it didn't actually save it. So let's go take a look at this for a second. If I go and select here, you'll notice that here are all of the invoices where the invoice total is greater than 1,000 and the balance due is greater than 0, which is what I think we're looking for up here. Actually, it's just, yeah, where the, yeah, so this is, it's when we pull the cursor, it's only selecting in information where the invoice, the balance due is greater than 0. So if I actually went and did this step myself, here's what would happen. It's essentially going and updating the credit total to this new value. So it's going to grab this and multiply by 0.1. So it's like basically, you know, 231. And it's going to add that to the credit total here. And that's going to be the new value. And it's only going to do that for these that have invoice totals greater than 1,000 and a balance due greater than 0, which is all of these. So let's go actually go run this for a second. And then let's select. And you'll see here, like this is, you kind of can see the math. These were 0 earlier. So what it is, it took 131.22 and it added it here to that, right? The invoice total, 10% of the invoice total added to the credit total is now the new value of the credit total. So let's do this. Let's reverse that process for a second. And to do that, I'm just going to reverse this and actually say, go set this equal to the credit total minus this. Oops, I don't know what that just did. All right, so I put it back. So now that I put it back, and I'm going to commit my change, I'm going to comment this code back out. And star this, /star. So what we're going to do is we are going to remove this code here, the rollback. So now it's going to run through, it's going to get the cursor, it's going to loop through that cursor row by row, and then it's going to update that data just like we just did, but it's going to do it in the procedure. And so let's go run the script out. Let's close this. All right. And just so we're clear, like if you want me to just select the whole thing, let's just run it by itself. Did the exact same thing. But what I want to make a note of here is that if I go and do a select from the table now, you'll see those changes. And let's do one thing. Let's actually roll back and see if that fixes it. Or roll back. And it did. Because we never committed. And so let's go back up. Let's run this one more time. I'm just going to run this by itself. All right, it did it again. There it goes. Now, what I could do is if I wanted, I could just put a commit right here. And so again, if I run this, let's double check, see if it's not there. Okay, I've just reversed it. Let's run this one more time. All right, ran the code. I select from the table, there it is, it made the changes. Let's roll back for a second, see what happens. I hit play. Changes are still there. And that is because we have committed the changes. So I'm going to put all this code back exactly how I started with it, and I'll let you play around with it and see what you can come up with. But hopefully this is making sense. In the text, we talked about how you can use ways of capturing a list. So in some cases, you may want to go and grab not a cursor of information like this, but an actual list of information, kind of like this. In coding circles, if you've ever heard of something called an array, that's what we're talking about. In Python, we call it a list. But basically what that means is, think about it like this. That is a list. We actually use it when we talk about where in this list of values. But in coding, in the world of coding, we also call it an array. So in the book, it talks about varray, it talks about associative arrays and all this. And these are all just different forms of ways to create lists and select a list into a variable. And then what you can do is, once we have a list of values and stored, or in this case, maybe they're stored in a grid format like this from our query, what we can then do is loop through it. So we can loop through and go, for the length of this array, which is 4, we can say, all right, grab this value, do something with it, go to the next, loop through it, and it can actually sit here and go through this value. So the varray, or not in this case, not the varray, we're actually gonna, let's make sure I've uncommented our code here. We're not going to use the varray or the associative arrays. We're just going to play around with this bulk collection. And basically what it's going to do, let's erase, is it's going through and it's selecting the vendor name, but it's going to bulk collect it into vendor names. And so what that is, if you look here, we actually declare this, there's two things we're doing. One is we're actually creating a type of name table. And this is a table of varchar 40. So what that's saying is we're going to create our own special data type that is a names called names table, and it's a table of varchar 40, which means that now we can create a list of varchar data that doesn't obviously expand beyond 40. So then what we're going to do is then we're going to create our next variable called vendor names, and it's going to be receiving that custom data type that we just created. Now what we'll do is we're going to select vendor name, we're going to bulk collect it into our custom list that we, with this custom data type from vendors where row number is less than 4, ordered by vendor ID. So if we run that without the bulk collect, it's essentially going and grabbing these first 3 vendors, and it's going to loop through. Now in this, what's cool about bulk collect is that once we have this variable called vendor names, we can just go refer to vendor names count, and it will automatically replace this with the 3. So we don't have to go in and hard code in how many times. We can just, it'll dynamically run. So if I set this to 8 and took this out again, we're going to get something that looks like this. It's going to give me 7 vendors, and that would then we'd loop through 1, 2, 3, 4, 5, 6, 7, because vendor names count as 7, and it's basically going to output the vendor name, the number of the loop we're on, and then when we want to refer to this specific value, what we do usually with an array or something is we just say, go give me vendor name parentheses 1, or I. And what this is going to do is, as it loops through, it's going to go grab. So think of it like this. Let's go back and I'll replace this, and imagine that we have a set of values here, and this is value 1, this is value 2, this is value 3. And if you're used to arrays, by the way, you're used to the idea that arrays start with a 0, 1, and 2, and PL SQL, it doesn't do that. So, but what's going to happen here is that if I refer to vendor name I, or in this case, vendor name 1, that's going to give me this value here. If I refer to vendor name 2 in my code, it's going to return this value here. Same for value 3. So let's watch what happens. Let's run this. And actually the reason why I did that is because I said less than 3. But you'll notice here, I can change this around. I can say, go pull me the first 7, so everything less than 8, and there it is. It's actually spitting out vendor name, and then it concatenates it so it says vendor name 1, and then it actually returns the first value of that list, or the first value of that bulk collect. And it will go through this and go until it gets to the 7th value of that list, which is this one. So that's what a collection is doing in a bulk collect. You can use other ones like array and stuff, but I'm choosing to go with this one because I think it's the most dynamic and useful. Other thing we want to touch on here is how we go about handling exceptions. So we've talked about the begin, we've talked about the declare. If you sometimes hide your code, you'll see that when you put it in these blocks, you can open it and close it. But once we've gone in and maybe we've done some kind of code and we want it to, in this case, we want to insert into general ledgers the following value. So we're just going to run a procedure that's going to go and insert. And then when it does that, it's going to then say 1 row is inserted. Now, what happens if there's some kind of error? So in the general ledgers table, there's actually a constraint. The account description has to be unique. So if I go back over here, we're going to try to input a value of 30, an account number of 30, and the description of cash. So let's take a second and I'll actually uncomment this code and show you when we run that statement, we get this violation. And the reason why is that there's actually a account number for 100 called cash. So if I go and update this, and let's say I'm just gonna call it miscellaneous. And now there is no account number for 130, so I should be able to insert this because that will give it a unique row. Sure enough, it did. If I select, you'll see there's 130 miscellaneous. Now what I'm going to do is I'm going to delete that for a second, and I'm going to commit that change, and I'm going to comment this all back out again. And the reason why I want to show you what's going to happen is that if I go in here and put in miscellaneous and run this procedure, what it's going to do is it's going to insert this value, and it's going to say one row was inserted, and it did that just fine, and the procedure ran just fine. But now let's go through and let's run it again. And what's going to happen here is that we should get an error message. And as you've seen in the book, there are ways we can custom code error messages. You can also use the kind of built-in error messages. So one of those built-in error messages, if you try to insert a duplicate value, you can actually say, if you capture that error and you see that error, then we can actually say, hey, when this specific error happens, we want to output some specific thing. You can also go through and capture all kinds of specific things, like if it's if you were trying to select some data into that variable and you got nothing back, you can have that spit out a specific error. So in this scenario, you'll see here that when I reran it, it actually gives me this information. That's because we're actually getting this error. If I run back here and let's delete it. I'll commit the change. I'm going to go run this one more time. See, one row was inserted just fine. And let's run it one more time. This time we get you attempted to insert a duplicate row. So pretty cool. This is again capturing, using the built-in error. If I want, I can also show you really quickly. Let's just run this. Hit save. Let's actually comment out this specific error here, and let's just run this whole thing. So it's going to run the insert just fine. Now let's see what happens. Now it says, unique constraint happened. So because it didn't actually have a specific instruction on what to do if that happens, you'll see here that what it did is it ran and it said, okay, well, what are the other exceptions we should handle? So here it actually ran, it outputs this and it says an unexpected error occurred, and then it actually outputs the SQL error message, which is this right here. We're familiar with some of these. So you can handle very specific errors, you can be more general. Pretty cool stuff. I'm going to replace this just so I can put this back how it was. I want to allow you to play with it if you want. All right, we are almost there. We just have to walk through a couple more real quick ones. So you might notice this execute immediately example. What we've done here is if I go and create a table called test. Now when I create that table, I could go through and I could run this statement, and what you'll see is that it's going to execute immediately the following string. And so execute immediately is just a way to take a string of text and feed in some SQL, and it's going to just execute it immediately like a SQL. And so let's run it. And what you'll see here is that it's going to run this and executes just fine. Now, if I ran it again, it's actually not going to give me an error message. And the reason why it should, right, if I actually went here and said drop table test1 and ran that, I get an error message. But what it's doing is saying, hey, when others, then null. What that means is if there is an error, just do nothing. So let's create this table. I could go and drop this table. You'll see there, I'll just create the table again. If I run this, you'll see here that it actually ran successfully, and I know it did because if I tried to drop the table, it would say that table doesn't exist. If I created this table now and I run it, it'll drop the table. I could run it again and it actually skips the errors. And this is helpful when you want to do something like a major drop script. You'll notice that our drop scripts that we've used has this command in it, and I think the errors the problems we're running into is we've been having issues where the execute immediately isn't working effectively, so that's why we're just giving you the drop script and let you tolerate the errors. But this is effectively how you should be able to ignore error messages. All right. Now, how do we go about executing code? Oh, sorry. This is not how we execute without displaying errors. This is how we use bind and substitution variables. So what this code here is doing is you have some variable called a bind variable, and what a bind variable does is that it allows us to capture from the user a specific value. So the way that you want to, if you ever want to prompt the user and say, you know, instead of like hard coding it in, like, because you've seen before, we've been hard coding in vendor 95 and stuff like that. What if we don't want to do that? What if we want it to be dynamic and we want to throw a pop-up and say, hey, give me an invoice number? Once we capture that substitution variable, this is what we call a substitution variable. Once we capture that, we can actually store it in a special variable called a bind variable. And that is what is used to store a substitution variable. And the substitution variable, again, is a user prompted value that they are going to enter. So what we'll do is we're going to run this code. And what it's going to do is it's going to capture a value from the user, and then it's going to store it in this invoice ID value. And then you'll see down here, we're going to go select invoice ID, invoice number from invoices where the invoice ID is equal to that value. And then it's going to actually go and then output whatever we just selected here. And it's going to, again, use our bind variable. So if I run this, sometimes these get a little big, so let's just run the whole thing and run it. So it's getting here, it's got to the part where it's at this part in the code and it says enter a value for invoice ID. So I'm just going to enter value of 1. I'll hit OK, and you know what, let me try running this as a script, and let's erase this. Value of 1, there we go, that's better. So in this case, it's better to run it as a script. But what you see happened here is that it actually captured the value 1 from the user, and then it ran a query to capture the invoice ID and the invoice number. And then it actually, once it captured that value for that invoice number, it went here and it actually outputs the value, which is invoice ID 1. So let's try it again. Let's go with invoice 4. There we go. So again, what we see happening here is that we are going and we are selecting the invoice ID from the invoice ID and the invoice number for that invoice value. And then we are using that to output the value. So it's actually grabbing. So I think what we're seeing here is that we're not selecting into anymore. We're actually just selecting, and it's just spitting out that value, and spitting out the response of that SQL statement. And then it's you know, telling us that it pulled that value. So we're going to do one last one here, and then we're going to wrap it up. And it's this: how do we make SQL dynamic? Now this is actually pretty cool, because this is going to apply to what we're going to talk about when we talk about how you connect a application to a backend. Because in some cases, you're not going to want to sit here and hard code in, I want to do this for vendor 95, vendor 94. What you want to do is you want to be able to feed in values through your application, and then let the procedure or the code, the procedural code that, you know, grab those variables and dynamically create SQL and run that SQL. And so to do that, we're actually going to string a bunch of code together and string actually SQL statements, make a SQL statement into this massive kind of string. So we're going to declare 3 variables: an invoice ID, terms ID, and dynamic SQL. So these are going to be used to go and capture an invoice ID and a terms ID. And you'll see that when we down here, we're going to capture a user variable. So to do that, we grab this ampersand at the very beginning of that variable. We're going to capture this invoice ID and a terms ID from the user. Then what we're going to do is we're going to create this variable that's a big varchar that's 400 characters long, and it's going to start with a update invoices, and it's going to be concatenated with set terms ID equal. It's going to be concatenating that, and then it's going to go capture. It's going to insert the value that we've fed it. It's going to then put in a space, and then it's going to say where the invoice ID equals, and it's going to concatenate that with the invoice ID that we've fed it in. So I mean, it's effectively doing the same thing as stringing together something that's going to, let's say, look like let's say we're going to update the term to 1 for vendor 114. It's effectively making that massive thing here, but it's putting it all in a string that looks like that. And then we're going to go execute it immediately, which, boom, you'll see right here, it's going to execute that entire string immediately. So that's kind of why we showed you that before. So really quickly, if I run the select statement, you'll see that for vendor, for the invoice ID 1 of 14, terms is 2. So let's go run this code. And what we'll do is for invoice 114, which we just looked at, I'm going to update the terms to 1 because earlier it was 2. So I'm going to run it, and it looks like it ran and completed successfully. Let's go see if it actually updated it. And sure enough, it did. If I ran it one more time and said for vendor 114, I'm going to update it to terms of 5. Sure enough, it works. All right. I know that was a lot, but that was basically giving you a pretty complete overview of all the cool stuff you can do with anonymous PL SQL. If you have any questions, let us know, and we'll be happy to answer them on the discussion board. Good luck and have fun with playing around with some of this.